Okay, so I've just checked and this comes out to be 2.2 millimeters. So just solving this equation here. So fairly straightforward just to plug in the numbers. Okay, so the next bit is a bit of a strange one, I have to say, but part of it is reading a vernier scale. So let's go down and do this one first. Now, the thing that everyone got wrong, or the thing that people got confused with, is this. Now, I'm going to zoom in on this one over here. Now, have a look. What a lot of you did is you tried to read the vernier scale as if this was the mark. And this is not the mark. The mark that you're reading from, like the base point, is here. Okay, it's the start of this vernier scale. So you're looking for where this starting point lines up on the main scale here. Okay, if you look up here where it's zeroed, look, it's clear that here's where the actual marker, here's where the sliding thing is up against the pencil. So the pencil would be here. And you can see that the scale is not there. The scale doesn't start here. The scale starts over here. So here is the 0 point. Okay, so if you'd spotted that, you wouldn't have made that mistake. Although it is a little bit confusing, I do admit. So if we come down here, let's think about how we would write this. So we've got 8. The main scale here is in centimeters. So we start here at 8. So we're going to go 8.1, 2, 3, 4, 5 before we get to the start of the vernier scale. So we can immediately write down it's 8.5 something. Then we're going to look for where on the vernier scale it lines up. Now, when you're zoomed in here, it's very hard to see. Actually, on the printout, it's clear that actually it's 1, 2, 3. It's this one here, which is lined up. So if it's, I'll make this a bit thinner. So 1, 2, 3, that's lined up. So that means that the actual reading is 8.53 centimeters. Okay, so that's the answer which we would put in up top. Let's go to that. Okay, so this one here, same deal. We will start here at 8. So the first number is 8, and then it's 1, 2, 3. So that's 1, 2, 3 millimeters. And then whereabouts on the vernier scale is it? We go 1, 2, 3, 4, 5, 6, 7, 8. So it's about 8 basically, isn't it? 1, 2, 3, 4, 5, 6, 7, 8. So it's this one which is lined up. And again, it's not very clear on this screen, but on the printout it's more clear. So 8.38. It's not millimeters, it's centimeters. Okay, so those are our two values. Now the rest of this question, it was quite hard to understand. So I'll write in here. So we started at 8.8. Sorry, it was 8.53 millimeters. Sorry, centimeters. So that's 85.3 millimeters. So we had to convert that into millimeters, and 83.8 millimeters after it had drawn these lines here. So hopefully you get the gist. They measure the length of the pencil, they draw all these lines, and the length of the pencil goes down. And what we've got to do is try and build a model for predicting how long it will take the pencil to go down in half to half of its original length. So the way to do this is to say how far, how many centimeters. Okay, so the length of the line drawn, how many centimeters can we draw per millimeter of pencil? Okay, so hopefully that makes sense. So the data that we've got, bring this down here. So the data that we've got says that we can draw, so 20 times 25, so that's 500 centimetres, 5 metres, 500 centimetres. And how much pencil do we use? So how much does the pencil change in length? Well, that's just the difference between these two values. So we can calculate that quickly now. It's 85.3 minus 83.8. Now, if we plug that into a calculator, it's 85.3 minus 83.8, and we get 1.5 millimeters. Okay, so we can do 50 centimeters for 1.5 millimeters of pencil. So if we do 500 divided by 1.5, we get 500 divided by 1.5, we get 333.3, and that's recurring, 33 ... Now, what units does this have? Weirdly, this is 333 centimeters of pencil line per millimeter of pencil lead. Okay, so it's a bit weird. We've kind of got a ratio of two distances, which I know is a bit strange, but hopefully that makes sense. Okay, now, that's how many we get per millimeter. We need to know how far we can draw with half the whole pencil lead. So the way to do that is, and again, this is a little bit confusing, this question, but the starting length of the pencil was 85.3. So half of that, L half, is 85.3 divided by 2 is 42.7. I've rounded that, millimeters. So we've got 42.7 millimeters to play with. And if we look down here, for every millimeter of pencil lead, we can draw 333.3 centimeters of pencil line. So what we need to do, if we've got 42.7 millimeters of pencil lead, that means we get 42.7 times by 333.33, which is equal to times answers 33.3. Okay, so that is 14,216.66 ... Okay, so now what units is this? Is in centimeters. So the answer here is 142 meters of pencil line. And then we've got the answer here in meters, so 142. So, bit of a strange question, but that is the correct answer. You might think, now that you hopefully have got a slightly better idea of what's actually going on, hopefully have a better idea of how that question would work, you might be able to find a faster way of doing it. I've done it in a fairly long-handed way to give you a sense of what this question was all about. Okay, so I think here, as always, thinking about the units is actually very helpful. So knowing that this quantity here had the units, 333.33, what is that? Okay, it's the number of centimetres I can draw for each millimetre of pencil lead that I lose. Okay, so once you've done that, it's a bit more simple to work out the answer to this question. Okay, quite a tricky